Example 7 in Stat 101, Examples Class 5, binomial situation, New Zealand tutataras. Remember, a binomial probability distribution results from a procedure that meets the following requirements. 4 requirements for a binomial. 1, the procedure has a fixed number of trials. Fixed number of trials. Requirement number 2, these trials must be independent. That is, the outcome of any individual trial does not affect the probability in the other trials. Number 3 requirement, each trial must have all outcomes classified into 2 categories, commonly referred to as either success or failure. So 2 outcomes, success and failure. And the 4th requirement for a binomial, the probability P of a success remains the same in all trials. Fixed probability of success. The 2 parameters needed for a binomial situation are n and p. 2 parameters for a binomial, n, the number of trials, and p, the fixed probability of success. The example for New Zealand tutataras, talking about populations of endangered tuatara. The mating cycle is long, so breeding success is critical. Suppose they have 5 fertile females in their program and past fertilizations suggest a 20% breeding success rate. First thing necessary, have we got a binomial situation? Fixed number of trials. We have 5 fertile females, so our fixed number of trials, if we like, n is 5. Trials must be independent, assuming the fertile females are all independent, and the trials are classified into either success or failure. So we will either have a hatch in this case, or we won't have a hatch. Will the fertilization be successful and result in a hatch or not? And the probability of success remains the same in all trials. Have we got a fixed probability of success? We're suggesting a 20% breeding success rate. P is 0.2. So we have a binomial situation with n is 5 and P is 0.2. In the question, find the probability of 2 hatches, at least 2 hatches, at most 2 hatches. At the bottom of the slide, we've constructed a frequency table using Excel to obtain the probabilities. You may wish to check these probabilities using the binomedist function in Excel. Check these values using binomedist. Remember, with the parameters, n is 5 and p is 0.2. Our binomial random variable, remember, x is the number of successful hatches. So x is the number of successful hatches, and we have the probability associated with each of those in the table. First question, the probability of 2 hatches, probability that x, our number of successful hatches, is 2, obtained directly from the table. X is exactly 2. Obtaining that value from the table below, probability of that happening is 0.205. Probability x is exactly 2, reading directly from the table, 0.205. and checking this in the binomdist function. Binomdist requires the value of x, the number of successes. In this case that's 2. The number of trials, n. In this case we've got 5. The fixed probability of success. The probability of success was 0.2. And cumulative, true or false, either 1 or 2. In this case, cumulative is false. We want the probability of exactly 2. Using that function, we'll return the probability of 0.205. Moving on to at least 2 hatches. At least 2 hatches, so x could be 2 and it could also be greater than 2. So probability x is greater than or equal to 2. Using the table we can add up the probabilities that we will require to get these, which are the probability x is 2 plus the probability x is 3 plus the probability x is 4 and also the probability that x is 5. All of those cases would give us this cumulative probability. Reading these values directly from the table, it will be adding together the 4 probabilities circled in black. 0.205, 0.051, 0.006 and 0.0003, giving a total of 0.262. Probability of at least 2 hatches for our tuatara, 0.262. The last question, at most 2 hatches. At most 2 hatches. So x could be 2 and also it could be less than 2. Less than or equal to 2 in this case, which will be adding together the probability that x is 0 to the probability that x is 1 and the probability that x is 2. Those 3 will give us our cumulative probability. So reading directly from the table, it will be the 3 values circled in blue. 0.328 plus 0.410 plus 0.205. So the probability of at most 2 hatches is 0.943. Using the function in Excel, if we want to check this, binomdist function, remember. So we're looking for the value of x. X would be 2 in this case. Fixed number of trials, n is 5. Fixed probability of success, still 0.2 for our successful hatch. And cumulative in this case would be true. We do want cumulative. We require the probabilities that x is 2 and also the values for 1 and 0. Cumulative, true, or typing in 1 returns the same value in Excel. Moving on to the expected value and the variance of a binomial. These are given on the formula sheet for Stat 101. If x is a binomial random variable with n the number of trials and p the fixed probability of success, then the expected value is simply n times p. And the variance of x, our binomial random variable, is n number of trials times p, probability of success, times q, which is probability of failure, or 1 minus p. So sometimes written as n times p times 1 minus p. So for our example, using the formula on the formula sheet, our expected value, in this case for the tuatara example, expected value of x, n times p, n was 5, p was 0.2, our expected value would be 5 times 0.2 equaling 1. Variance, n times p times q, n is 5, p is 0.2, and 1 minus p would be 0.8. So probability of success is 0.2, probability of failure would be 0.8. So 5 times 0.2 times 0.8 gives a variance of 0.8. And should we wish the standard deviation, we would use the square root at that point. Remember, standard deviation, always the square root of the variance. And that's the end of example 7.